Hey there, Ravens. Welcome back. Time for Atomic Theory Part 4, talking specifically about the subatomic particles. Atomic structure. The atom is the smallest particle of matter that still retains the characteristics of whatever particular element type that it is. Okay, recall atoms and elements, similar but not the same thing. Okay, so the atom is the individual particle, an element is what type of atom you have. Atoms are not able to be broken down further by chemical means. They're held together by something called the strong force or the strong nuclear force, and that's the force that holds the protons and neutrons together in the nucleus. Atoms are, here's a cool video, so watch.
This is Cambridge University in England, where Ernest Rutherford, Niels Bohr, and other famous physicists did scientific research. Imagine a single atom the size of this courtyard.
If we think of that being the size of an atom, then the size of the nucleus would only be 1 millimeter in diameter. That's a bit smaller than this little grain of sand that I've got in my hand here. In other words, what it means is atoms are essentially empty space.
Now, how can we reconcile that with the fact that matter is matter, and my hands don't go through one another? Well, that's crazy, because if it's mostly empty space, they should pass right through one another. But what we understand now is, in fact, the reason my hands don't go through one another is that while the space is empty, what it's filled with is really electric fields. When the electrons come within a very small distance of each other, they begin to repel each other, and that's why things appear to be solid when they are actually not. Now, you may think that I'm sitting on this chair, but actually that's not true. I'm actually hovering over this chair 10 to the minus 8 centimeters over this chair because of the electrons of my body are repelling the electrons of this chair.
Think about that. Okay, moving on. The nucleus, the central part of the atom. Very, very small volume when compared to the size of the whole atom. It is, recall, density refers to the distance between the particles. Almost all of the mass of the atom is found in the nucleus. So it's high mass, very, very, very small space. Inside the nucleus is composed of protons, which are positively charged. The number of protons determines the kind of atom that it is. And all protons have a relative mass of 1 AMU. Also inside the nucleus we find the neutron, and the neutron has no charge, it's neutral. The reason it's neutral is because it's actually, we now know, composed of an electron and a proton together. So in beta decay we learned that the electron will split off and take its fragment of a piece of mass with it and its negative charge and leaves the positive charge and most of the mass. Okay, so a neutron has almost the same mass as a proton. Both protons and neutrons are found in the nucleus. They make up the nucleus. Make sure you've gotten past the point. There is no real inside or outside of the nucleus. The nucleus just is, and it is the center of the atom. Surrounding the nucleus, we have the electrons. Negatively charged, very, very, very small mass, yet an equal amount of charge as the proton, only on the opposite end, so it's negative. And this is where we get all of the volume, the space of the atom. In the space, because the electrons are so tiny, the space that they take up is so very small, but the amount of space that they need to spin around the atom is very large. And that's where the volume comes in, is that the amount of space that the electron needs to move in is big, but the size of the electron itself is very, very small. Okay, so you got to wrap your head around that. Okay, the amount of space the electron needs to spin around the nucleus of the atom is large, but the size of the electron itself is quite small. And we'll get more into electrons in a few parts from now. All right, so let's end with an overview of atomic structure. This video also does a really nice job talking about isotopes. And I'm going to try to see if I can fast forward it because this is really slow to get started.
Atoms are divided into two major parts: a centrally located nucleus that contains positively charged protons and uncharged neutrons, and one or more orbitals, regions in the space surrounding the nucleus in which negatively charged particles, called electrons, travel about continuously at nearly the speed of light. Protons and neutrons each have a mass approximately 1,836 times greater than that of electrons. However, in spite of the huge difference in mass between protons and electrons, their electrical charges, though opposite, are equal in magnitude. As atoms have equal numbers of protons and electrons, they are electrically neutral. Every element has a unique atomic number. The atomic number of an element corresponds to the number of protons found in the nuclei of its atoms. For example, hydrogen atoms have one proton and an atomic number of 1. Helium atoms have 2 protons and an atomic number of 2. While carbon atoms, which form the atomic skeleton of all the larger molecules found in living organisms, have 6 protons in their nucleus, giving them an atomic number of 6. While every atom of a given element has the same number of protons, the number of neutrons contained in the nucleus of atoms of the same element can vary. For example, carbon atoms can have 4, 5, 6, 7, 8, or 9 neutrons. Each of these different forms of carbon is referred to as an isotope. Isotopes of a given element like carbon are virtually identical to one another in terms of chemical reactivity, but sometimes vary in their physical properties. For example, the nuclei of some isotopes, called radioactive isotopes, spontaneously disintegrate, releasing radiation in the process. In the case of carbon, the isotopes carbon-12 and 13 are stable, while carbon isotopes 10, 11, 14, and 15 are radioactive. The existence of radioactive isotopes in carbon and other elements allows scientists to carry out tasks as different as dating the fossil remains of long-dead organisms to studying the physiology of the human mind. However, it is the behavior of electrons in an atom's outer orbitals that determines how the ions and molecules critical to life are formed.
Okay, and that ends our segment for today. I'll see you again soon.